In this video, we're going to go through a bunch of examples of solving Pythagorean theorem problems where I can have sides that are in this a root b form. Two reminders: Pythagorean theorem, if I have a right triangle with legs a and b, hypotenuse c, I know that a squared plus b squared equals c squared. Another reminder, if I have something of the form a root b, and I'm trying to square it, for instance, putting it into Pythagorean theorem, what will end up happening is I'll square both of these terms. When I square a, I'll get whatever a squared is, which, a times a. But when I square the square root of b, I will just get b. The square and the square root pretty much cancel out. So let's go through 6 examples, see how it works, and hopefully this will clear up any questions you might have. Here's my first one. Find the value of x in the triangle below. So first, identify c. c is going to be x. So when I'm doing a squared plus b squared equals c squared, I'll have the x squared by itself on the right-hand side. A and b can go in any order, so I'll put this 2 root 3 as a and 2 as b. I'm going to do a little bit of computation here. So I square the 2 root 3. 2 squared is 4. Root 3 squared is 3. 2 squared is 4. Next, I'll multiply the 4 times 3 and get 12. And then I'll add the 12 and 4 to get 16. To solve this, I'm going to take the square root of both sides, and I want to come up with an exact answer, and if it's different, a decimal approximation. So in here, let's just assume you didn't remember, and I check to see what the square root of 16 is, and hey, it's 4. Not something that I rounded, but actually exactly equal to 4. And so that's my exact answer, and I don't need a decimal approximation because I didn't approximate this. Before I go into the next problem, I do want to address this is the case of what's called a special right triangle, where if I have 2 root 3, 4, or some multiple of that, this would be what's called a 30, 60, 90 triangle. I'm not putting up a video for the special right triangles right now. They can be very important, but you can get around the problems for this context by knowing other methods, but it's worth pointing out that this is a special right triangle. It's one of our 2 special right triangles. Okay, next example. First things first, identify c, so go across in the right angle. C will be x, so I'll put x squared by itself. A and b, the order doesn't matter, so I could have root 5 squared plus root 2 squared. If I square the square root of 5, I just get 5. If I square the square root of 2, I just get 2. 5 plus 2 is 7. I take the square root of both sides, and I'll go to the calculator to get the decimal approximation. So the square root of 7 is about 2.646. So x is approximately 2.646. If I want the exact answer, then I will break down the 7. But 7's already prime, it does not break down. I look for pairs. I don't have any pairs. So the only thing I have is a root 7. The 7 is still in the square root because it did not pair off with any other numbers. Okay, another problem, same method. Find c. In this case, c is root 26. So I will have a square root of 26 squared by itself. A and b can be any order, so I'll have 2 root 3 squared for my a squared, and x squared for my b squared. I'll go through and do the math. So 2 squared is 4. Root 3 squared is 3. Those are multiplied together. The square root of 26 squared is just 26. 4 times 3 is 12. I'm going to subtract the 12 from both sides. And I will get x squared equals 14. And then I will take the square root of both sides. So the square root of 14 is approximately 3.742. So x is about 3.74, yeah, 3.742. And as a math teacher, I like getting the exact answer. To do that, I will break down the 14. So 14 is 2 times 7. 2 is prime. 7 is also prime. I don't have any pairs, so I'll just have the 2 times 7 left over in the square root. So my exact answer will be x equals square root of 14. It actually does not break down any further. All right, next problem. So in here, I start off the same way. X will be c, so I'll have that by itself. I have root 2 and root 2 as a and b. The square root of 2 squared is just 2. The square root of 2 squared is still just 2. 2 plus 2 is 4. And now, when I take the square root of both sides, again, I shouldn't need to, but let's just say I'm not thinking carefully. Go to the calculator, square root of 4, and I get that x is exactly equal to 2. Okay, before I move on to the last two examples, this is the case of a special right triangle. It's called a 45-45-90. So 45 degrees, 45 degrees, also referred to as an isosceles right triangle. And whenever you have this case, you'll have these two sides will be the same. And this side will be that times root 2. Again, I'm not using this video to teach special right triangles, but it's worth pointing out that this is one of our special right triangles, either 30, 60, 90, or in this case, 45, 45, 90. Okay, getting some bigger numbers here, but we start off the same way. Find c. c in this case is 12 root 2, so I will have a 12 root 2 squared. A and b, doesn't matter the order, so I'll have x squared plus 8 root 3 squared. I'll bring down my x squared. 8 root 3 squared, I will square the 8, get 64. Square the root 3 and get 3. For this side, I will square the 12 and get 144. Square the root 2 and get 2. Now, you may be able to do this in your head. I'll go to the calculator just to show it. So 64 times 3 is the first thing I need to do. 64 times 3, and that gives me 192. So I'll have an x squared plus 192 equals. I'll do 144 times 2 and get 288. Then I will subtract the 192 from both sides. So 288 minus 192 gives me 96. And to solve this, to finish it off, I need to get rid of the squared by taking square roots. I can go to the calculator, take the square root and see, oh, it's a decimal, so that's not exact. In rounding, I get 9.798. So x is approximately 9.798. But if I wanted the exact answer, what I'll do is I will end up breaking down the 96. So I'll take my 96 and find two numbers that go in there. Now, you might know right off your head that, 8's going to go in there, 16's going to go in there, but let's just say that we didn't see that. Well, since this is even, I know I can take out a 2. So if I take out a 2, 96 divided by 2, I get 48. So 2 times 48, 2 is prime. Now that I'm even smaller, I know many things. I can keep on taking out 2's because I know this is still even. So that would give me 2, and when I divide by 2, I'll get 24. And I could keep going. I'll break this down a little bit quicker. So 24 is 4 times 6, 6 and 4, so 4 is 2 times 2, 6 is 2 times 3. And now I look for pairs. So I have a pair of 2's, that comes out. I have another pair of 2's, that comes out. I have no more pairs, but I have a 2 and a 3 left over, so those stay in the square root. And my final answer, after all is said and done, will be 4 square root of 6. Okay, one more example. Find the value of x in the triangle below. So first, figure out what c is. Go across from the right angle, c will be 3 root 6, so on the right-hand side, I'll have 3 root 6 squared. Doesn't matter which one's a and b, so I'll make x my a, I'll make 2 root 5 my b, and now I just work it out. So bring down the x squared, square the 2, and get 4, square the root 5, and get 5. On the right-hand side, square the 3, and get 9, square the root 6, and get 6. Now do some multiplication, so I get x squared plus 20 equals 54. Subtract the 20 from both sides, and I will get x squared equals 34. To get rid of the squared, I'll take square roots of both sides. So let's take the square root of 34. I get approximately 5.831. So x is approximately 5.831. And if I want an exact answer, I'll break down the 34. So 34 is even. I can take out a 2. When I divide 34 by 2, I get 17. 2 is prime. 17 is also prime. There are no pairs. Nothing comes out. So I just have the root of 2 times 17, but 2 times 17 was 34. So the exact answer is x equals root 34, and this one does not break down further. Okay, there's a worksheet in the description below for this video or the previous video, and I hope this helped clear up any questions.